Hello, great hosts, and in this video we're going to be looking at number patterns. So we're going to be looking at number pattern sequences and series, and we're going to be looking at some of the basic approaches, shortcuts, and ways of proving, and so on and so forth. So I'm just going to set this aside for now. So what we're going to do is just get down to the theory first. Um, no, this is just a revision, so I'm not going to get too much into detail. All right, so we're looking at number patterns, and so that's just number patterns. So in terms of number patterns, there were like three different number patterns that we were taught. We were taught three different types of patterns, and one of those patterns were quadratic number patterns, and the other was geometric number patterns and arithmetic number patterns, of which arithmetic number patterns were just essentially linear number patterns. But nonetheless, we're going to get started with the quadratic patterns. Okay, so the idea of a quadratic number pattern is that we're going to be taking things each and every time and we're just subtracting them from one another. However, the problem is the things that we're going to be subtracting from each other, we're not going to be getting the same value out of that. So what I mean is, if we have an arbitrary pattern A, B, C, D going on until thy kingdom come, if I'm taking these values and subtracting them each, the values that I'm going to be getting are not the same. However, if I take these values themselves and subtract them, I'm actually going to get values that are the same. This sounds a little crookedly interesting. So what I'm going to do is I'm going to take a sample question, and then we're going to take this sample question and then attempt it. So we're going to attempt to try and find the nth term, and I'm going to explain as we go really what the nth term and all those other kind of stuff. We're going to be explaining the nth term and so on and so forth for each of these number patterns, and then we get down to business from there. So I'm gonna just look for a question from one of these past papers. Okay, okay, this one looks interesting. I'm gonna grab this one. Um, right, I'm gonna do a screen grab, and this comes out of the November 2014 final paper. So let me just grab this and paste it here. So this is on geometric number patterns. I'm just gonna maximize this a little bit. So this is, as you can see, from November 2014. So we're given a quadratic number pattern, okay, and the one has to find the value of p, which is just the next value successing after that, and find the general formula and whatever question that next one is. So these are not too much of a big deal. So let's begin by analyzing this pattern that we have here. We've got a negative 1, so let me just grab the pen. So we've got a negative 1, negative 7, negative 11, and p. So that's what we have here. However, I want to find the differences. So to find these differences, I'm just going to be subtracting these values here. So I'm going to begin by this negative 7 minus negative 1. So negative 7 minus negative 1 is like negative 6. If my maths allows me, I'm guessing. Let me just hook up the calculator in case we'll need it. So let's set this aside. So what we just said there, just to double check, we said this is negative 7 minus the negative 1 that we have there, and that's negative 6. Oh, beautiful. My mental math is actually good. Okay, then the negative 11 minus the negative 7. We will not get a negative 6 because this is a quadratic number pattern. We're not going to get the same values. So what I get there is negative 4. Right, we'll set this aside. So we just get a negative 4 out of that. So I'm just going to jot that down, negative 4. And then this will just give me p minus negative 11. Nothing fancy for that one. However, the thing is now, because this is a quadratic number pattern, if I actually subtract these values, what I'm actually going to get is equal. So negative 4 minus negative 6. I'm going to consider that calculation, and I'll bring back the calculator up. So here, so what we have there is negative 4 minus negative 6, and then I'm gonna have 2. So what this means is me performing that subtraction to get a 2, I would also get a 2 for the other one. So this gives me just 2, but arbitrarily speaking, I'm also gonna get a 2 for that. Okay, so that's all we need. However, the question there wants us to give the value of p, but I can make use of algebra to actually calculate this, or I can just blindly go into this one. Let's blindly go into it. Well, according to this calculation, we just said that p minus negative 11 minus 4 is 2. So I'm going to make an algebraic equation out of that and blindly work through it. So for this, we just said now that p minus negative 11, or I can just simplify things, then just say this is p plus 11. I mean, you should be good at maths at this point in time. So p plus 11 minus negative 4 has to give me a 2 based on this analogy that I have there. So p plus 11 minus 4 would actually sum up perfectly to, let me just put this aside there. Okay, so I'm gonna simplify that by means of the calculator. So what I have there is just 11 minus negative 4. That just becomes something like 11 plus 4. And this is 15. Okay, so that's just 15. So I'm gonna set it aside again. So I'm just gonna get 15 for that, for this part. So I get p plus 15 is equals to 4. However, my p would be 4 minus 15. So I'm just gonna grab the calculator. Welcome back. So for that, it's going to be 4 minus 15. And then for that, I get a negative 11. So that's negative 11 being the value of my p. This doesn't sound right. Does it sound right? We don't know. Okay, so I get a negative 11. So that's a 4 minus 15, and that gave me a negative 11. But we're going to test this out in a bit by means of using the nth term. So I'm just going to jot that down, so we're not really that sure about not 14. I got a negative 11 again. Anyways, so now that we have this in mind, let's see how can we find the nth term in this scenario. So in this scenario, I'm just gonna grab a different color for this. Okay, the green looks cool. Okay, so based on the fact that it's a quadratic number pattern, we should keep in mind that the first layer is the layer of 2a, and the next layer is the layer of 3a plus b, and the last layer is the layer of a plus b plus c. Okay, and I'm of course taking my first values of each pattern that arises from my quadratic number pattern. So I'm going to start from the bottom going up, of course. So I'm going to first say that 2a is equals to 2, and therefore a is equals to 1, because if I solve for a, I get 1. Then the next layer, 3a plus b, is equals to that value, which is negative 6. However, this is a recursion, so I know my a to be 1. So this is 3 multiplied by 1 plus b is equals to negative 6. Then 3 multiplied by 1 is just 3, so this is 3 plus b. 3 plus b is actually equal to negative 6. Then I want to transpose the 3. This will be 3 negative 6 minus 3. So negative 6 minus 3 is about negative 9 or so. So that's that's negative 9, so my b is negative 9. And then my last layer there, that's going to be an a plus b plus c, is going to be negative 1. And then I substitute that, so I've got 1 minus 9, because that's what I have, plus c is equals to negative 1. And 1 minus 9 is just like negative 9 plus 1. That's like a negative 8, plus c is negative 1. Then I get a c of negative 1 plus 8. That's like 8 minus 1. That's like 7. Okay. Then what I would get for my nth term for this is I would have t of n is going to be, well, we know we should have an squared plus bn plus c. Then let's simplify this. My a is just 1, so I should just have an n squared there. Then my b is negative 9, so I'm going to have a negative 9n, and my c is 7, so I'm going to have a plus 7. Okay, then I want to really test this thing that I just came up with. Let's test it out with trying to find this term number 3. Okay, let's suppose we don't know term number 3. We should really get negative 11 out of this formula that we just made. So I'm going to grab the calculator. Okay, so there goes my calculator, and then we're going to perform the test as if we didn't know term number 3. So instead of n, I'm going to be using 3 in this case. So I've got a 3 squared minus 9 multiplied by 3 plus 7, and we get negative 11. So it works. However, our p that we were finding previously, which sounded so awkward, was term number 4. Let's test that out. So I've got this. I'm gonna replace that and try and find term number 4, and we should be getting 13. So that really didn't, that analogy we used before just didn't work. Okay, but yes, the way in which we just found the p is another way you can actually do it in your question paper. But nonetheless, based on our calculation, we went on with p plus 11 minus negative 4. So I'm going to go with this as if I was solving it by means of the calculator. So if I was going to solve this with the calculator, I would say x, because I don't have the p, plus 11 minus negative 4, and this should be equal to a 4. Why is this equal to a 4? This should be equal to a 2. Where did I get the 4? Oh crap. That's the reason why. That's the reason why we got it wrong. So the 13, negative 13 works. That's why. So I made the wrong substitution for that one. My bad. So here it should have been a 2, because p, this minus this should be giving us that, which is the 2 and the 2, and we should be ending up with negative 13. Anyways, that just answers that part of it. Then we told the first difference between the two consecutive terms of the first two consecutive terms of the sequence is 96. Calculate the value of these two terms. What on earth did I just read now? The first difference between the two consecutive terms of the sequence is 96. So what they're saying is the first difference. So remember, the first differences are these numbers that we have here. Okay, those are what our first differences are. And they're saying the first difference between two consecutive terms. So somewhere along the way here, there are two terms that follow one another, and they, when added, give you 96. Then they want the value of these two terms. This is an arithmetic number pattern type of a problem. So what I'm going to do is I'm just going to grab on and just set some space for myself. Okay, we will not need most of this. Okay, so what are we going, how do we approach this question? Well, let's break it down and let's put everything that we know on the table. So right now on this point here, I'm just going to write down the values that I already know. Here I just found out my p to be negative 13, and negative 13 minus negative 11. So let's see, negative 13 minus negative 11 is negative 2. So the value that I have there is actually a negative 2. um negative 2. Okay, so we're just imagining this as if it was a linear number pattern. So they're saying somewhere along the way of this linear number pattern, there are two values that add up to 96. That is a very interesting question. So the first difference between two consecutive terms of the sequence adds up to 96. So here's the first difference between two consecutive terms. Oh, cool. Okay, actually, I get this. So they're saying here somewhere there's a term and another term, and when they are both added together, they get 96. When they add up those two values, they get a 96. Okay, so what does this mean? Well, if we look at all the other terms added together, we actually get the first difference. Okay, um okay, here, so if we look at let's say for instance, wait, let me see if I'm breaking down this question. The first difference between two consecutive terms of the sequence is 96. Two consecutive terms, the first difference between, so what they're saying is the first difference between two consecutive terms of the sequence is 96. So they're saying somewhere there's a 96, and we need to find out these two consecutive terms. Okay, so what are those two consecutive terms? So we're just saying these values, they continue all the way up to a 96, and we have to figure out what those two numbers are. So what I can do is find the term number in this pattern and then break it down to find the two that form out of that. So we'll take this as if it was a arithmetic number pattern. And if it was an arithmetic number pattern, I'll start off by finding the D, right? And the D is, well, that's just a common difference. And the common difference to find it is just subtracting T2 minus T1, and I'll get a common difference. And we already know what the common difference is. This is just a 2, right? So for those who may have been lost, the common difference would be T2 minus T1. Remember, we're trying to find what's the term number of 90 that will give me a 96. So I'm trying to dig into this arithmetic number pattern. So T2 minus T1. So I'm going to go negative 4 minus negative 6. So negative 4 minus negative 6. I know we already have these values, but I want to just make sure. Negative 4 minus negative 6 gave us a positive 2. So that's really what my common difference is going to be in this case. So that's just a 2. Okay, then we know that the term number, or nth term, is going to be equal to no, not a, the first term, plus n minus 1 multiplied by d. This is a formula for the nth term of an arithmetic number pattern. Okay, then we know this is a1 plus. In fact, I actually know what a is. The a would be negative 6. Remember, a is the first term, plus n minus 1, and then d is just my common difference, and that's just a 2, nothing fancy there. Negative 6 plus 2n minus 2. Beautiful, beautiful, elegant. 2n, and the negative 6 minus 2 is like 6 plus 2 with a negative. So 6, 7, 8, this should give us like a negative 8. So this pattern there follows this formula. So now I need to figure out which one is 96. So to do that, I'm essentially finding out which one would give me that 96. I'm finding which term number would give me 96, and I'll do it as such. So for that, then I would transpose my 8, or in fact, because I have a calculator that's better than yours, I'm going to use mine instead to do that direct solve. Okay, so we're gonna take that's just 96 is equal to 2n. Instead of n, I'm gonna use an x, because well, that's the calculator, and then shift solve and equal to. That's term number 52. Okay, so what this means is, on this arithmetic number pattern, this is term number 52. But we haven't answered the question. We need to find the actual two consecutive terms that add up to this 96. Well, let's break it down now. So, if we look at these two number patterns and we begin making like some sort of a direct comparison between the two to actually getting the term number, we'll realize that here we've got first term. Let me get a different color because I don't think anything that I did there is visible. Let's grab a red because, well, it looks cool. So there I've got a term number. So that's 1, 1, 2, 2, 3, 3. And we keep going until we get to 52. Then clearly the one before that was term number 52. And the one after that is term number 53. Remember, I have the general formula. So remember, 1, 1, 2, 2, 3, 3. And we keep going until we get to 52, 52, 53 something. We don't care about that something in this case. However, we know the 52. So we're going to find the 52nd term and the 53rd term. That's how we're going to find those two consecutive terms that add up to this 96. So what I'm going to then do is I'm just going to clear this out, and then, oh god, I just erased this form. There, I actually have the nth term. There it is. So I'm going to use the nth term to find out which one is 52. So there, let me grab the pen again. So voila, then I'm just gonna phase that out. So now I'm just gonna figure out which one is term number 52. So what is the term number? So I'm gonna be having n of 52 squared minus 9, 52 plus 7, and then we let the calculator do the work for us. So I'm gonna grab that, and then we'll just punch it in as it is. So term 52 squared minus 9, 52 plus 7, and this is equal to 2224. Nothing fancy, the 2224. That is the term, one of the term numbers. 2252, was it? No, 2243. Okay, yes, 2243. That's term 52. And then we have term number 53. So that's the other term. So this would be 53 squared. Oops. 53 squared minus 9. 53. 53 plus 7. And then we add them up. And then we see what we get. So for that, that's just as is, easy maths. 53 squared minus 9, 53 plus 7, and booyah, and that's just 2339. So that's 2339, and those are the two consecutive terms that will give me the 98. Okay, so you're probably like, but Nash, what are you doing? I mean, that doesn't feel right. Yes, obviously, because they have to be negative to give us the 96. Yes. Okay. Um, that's it. Yep, that's very much it. Okay. So let's close off this one, and then in the next coming video, we'll then look at more questions on number patterns, sequences, and series. See you in the next one.